Does next generation GSE deliver on its promise? It's all about the actual enhanced GSEs and what impact, what they can deliver for us in our business in ground handling. I'd like to welcome to the stage the next group of panelists for discussion. It's Alessandro Pastorelli, General Manager of TCR Italia. Welcome, Alessandro. Again, team colleague and friend Bartu Kogul, Head of GSE Planning at Donata. Bartu, welcome, and good afternoon. I'd like to welcome Mr. Harvey Sawyers, Head of Global Excellence at Swissport. Harvey, welcome, and good afternoon. And finally, moderating for us is Mr. Steve Savage, Senior Safety Data Analysis for Ground Operations here at IATA. Thank you.
Chair's a bit narrow. Well, you're here now, probably walking off with it.
Afternoon, everybody. Well, here we are, rehoning our skills in presentation, having acquired a whole lot of skills in Zoom and Teams and that sort of thing. Ground damage is caused by ground support equipment is a perennial topic in our industry. IATA undertook some investigations and conducted a study to try to establish the cost of that damage, and more specifically, what of those costs are attributable to GSE. The annual direct costs of the cost of actually fixing the aircraft are expected to more than double over the next 15 years. And the same is expected to happen to the indirect costs. All those other costs, like keeping the passengers happy, booking them on another carrier, dealing with the crew overrunning their hours, etc., etc. In fact, if we don't do anything about it, ground damage costs are going to rise to $9.7 billion annually within the next 15 years. Drilling down into the detail of the GSE to try and see where we should be focusing our efforts, it wasn't surprising to us to see that the GSE that docks at the aircraft are the type that cause the most damage. Of the 4 GSE that account for over 40% of the annual damage costs are passenger stairs at $620 million, belt loaders at $610 million, cargo loaders at $560 million, and passenger boarding bridges at $280 million. You are by now more than likely very aware of the additional features that were introduced to the GSE requirements in the Airport Handling Manual for reducing ground damage. What the study looked at in detail was whether we could quantify the expected ground damage cost prevention benefits by using equipment with features while considering factors such as the retirement rate of the old equipment, the rate of buying new equipment with or without, sometimes, unfortunately, these damage prevention systems, and the retrofitting of existing equipment. The study looked at 2 levels of utilization of GSE with the ground damage prevention features, namely 50% and 75%. So, for example, for the passenger stairs, the amount that needs to be set aside each time a passenger stair is used will drop from $33 down to $27 per instance of use if 40% of all of the passenger stairs globally are fitted with these enhancements, and finally down to $21 per instance of use if 75% of the passenger stairs globally are fitted with these damage prevention systems. For belt loaders, the corresponding figures are a drop from $16.70 down through $10.70 at the 40% level and down to $7.30 at the 75% level. For the cargo loaders and the passenger boarding bridges, the corresponding figures are $31.40 down through $23.10 at the 40% level, $15.70 at the 75% level, and you can see for the passenger boarding bridges, we dropped down from $13.50 to $8.90. As one of my previous speakers said, here we go with the let's go figures. Huh? So if we take a typical turnaround, which involves a passenger stair, a belt loader, and a cargo loader, what is going to happen here is that excuse me. If we take the investment in the enhanced equipment, we can expect the cost of ground damage per turn to drop by $36.80 if each and every one of those pieces of equipment used in that turn are implemented at the 75% level globally. So this all looks very promising, but we need to check if it actually pans out in life on the ramp. The problem is that for damage prevention, we are trying to measure what didn't happen, which is kind of awkward. Fortunately, we thought at the time, this type of GSE is fitted with a log, which enables the equipment to record when the system is triggered. There are, of course, false triggers, and there are also ways in which the system alerts the operator of an impending incident, and so the incident didn't happen. And in fact, the system almost didn't get triggered. But nevertheless, we thought that this log would give us a good idea of the number of times the system is triggered, and therefore preventing something from happening. For this project, we have two ground service providers, namely Swissport and Donata, and we have a GSE leasing company, namely TCR. The GSPs each selected an airport at which they operate enhanced GSE, and TCR looked at their GSE fleet. And over the course of some weeks, they have been monitoring the damage prevention system logs and collecting the data to see if they can establish the number of turns performed without the system triggering, with the aim of comparing this with the forecast results. We are very early days with this. We're expecting some preliminary results by the time we get to July, and hopefully a bit of a report in Q3. Nevertheless, we'd like to share with you what we have so far. And so I'd like to call on Harvey Sawyers to come and kick this off.
Thanks, Steve. Good afternoon, everyone. Okay, so we took a fairly standard station, one of our European stations, which handles about 20,000 flights a year. It's a fairly standard for us in terms of passenger and cargo freight operations, so it had a good mix of GSE assets. Volumes for the flights are starting to ramp up, so they've had a fairly quiet start to the year, but they're starting to ramp up now, so we felt that that would give us a good representation of the data. And it's also a station that's been using enhanced GSE for a number of years now, so they're quite well versed. So I thought we'd get some useful data out of that station because they're using it effectively. So on that station, we focused on belt loaders and cargo loaders. They have 8 TLD MBLs with the ASD system, and then 4 Trapel Champ 70s and 2 Trapel Champ 140s with ACAS systems fitted. And we took a number of weeks, 3 weeks, to extract the data from those assets. As Steve touched, some of the data from these assets is time limited, so the requirement is to keep revisiting those assets to extract the data. But what we found across those 14 over the 3 weeks was there's no historical reporting of incidents on the assets. And actually for that station, we had nothing through our internal reporting system to show that they'd had any triggers against those assets, which suggests that the systems are working and doing what they need to. Coincidentally, yesterday, we actually had a report from the station, and it is pure coincidence that they had an incident with one of the loaders that had made contact with an aircraft, but the ACAS system triggered, it stopped the asset, and there was no damage done at all. So there's a prime example of something where the system is working, and it's done its job and prevented any damage to the aircraft. Now, if we take, is there a graphic on that? There's a graphic. So if we take that from the figures that Steve's put together for IATA, in terms of cost avoidance, industry cost avoidance, that's not my cost avoidance as a handler, because I'm not going to save $16 a turn. But across the whole industry, in terms of those 8 units and the number of flights they handle, the math says that across that fleet each day, they save $125 per unit, which means we're, in theory, avoiding about $1,000 just for that fleet of ACE assets, which is around $365K per year in terms of the industry, the damage to the industry cost. And for the cargo loaders, the 6 units, it's a similar figure. It's slightly higher because they're bigger units and there's more cost avoidance. So they, in theory, saving about another $1,100, which equates to just over $400K. So those 14 units alone are saving the industry around $750,000 per annum in just using those from the enhanced GSE and the avoidance of any damage to aircraft. And then I'll hand over to Alessandro from TCR.
Thank you. Thank you, Harvey.
Thanks.
Good afternoon. Just a very quick couple of words for those of you who don't know TCR. As Stephen was saying, we are an operational leasing company. We provide full service rental of ground support equipment. We're not a manufacturer. We're not a ground service provider. So from this perspective, we have a slightly different approach. TCR is currently present in 14 countries around the world, from North America to Australasia, all the way down to New Zealand. We own and manage, on behalf of our customers, 35,000 plus assets. We have 75 workshops for our technicians take care of our GSE, and we are present in 174 airports worldwide. So we took a little bit of a different approach, of course, because not being a ground service provider, we can't account for the number of turns that are handled by our GSE. We see utilization. We rent GSE to our different customers. So what we did, we took a slightly different approach. Of course, the information we gather comes namely from our customers' reporting. So everything that we have as TCR comes directly from our customers reporting into our system. So what we did was we pulled data out of our health and safety management system, where we log all the information we have, of course, regarding all our workshop, what happens to our workers, but also, of course, anything regarding GSE, be it accidents or ground damage. So what we did is we pulled data for the current fiscal year. For TCR, fiscal year runs from the 1st of July to the 30th of June. So we did this exercise with Stephen a few weeks ago. So we were looking at the 9 months between July 21 and March 22. What we found out from our system pulling the data was that the GSE we are renting to our customers had reported 25 accident incidents involving aircraft damage. These 25 incidents had happened in the same 4 countries, in 4 different countries within our network. 13 of the 25 were involving GSE of, let's say, the critical families which are supposed to be equipped with enhanced systems. So the belt loaders, passenger stairs, cargo loaders, and the lifts. We don't operate passenger boarding bridges. In these 4 countries alone, for these 4 families, we're operating almost 1,700 units. So we had 25 incidents over a family, a community of 1,700 total units. So as you can see from the graph, the biggest culprit, and from what we've been observing, is the stairs. They account for 2/3 of these incidents, followed by the loaders and the belt loaders. Now, the lifts do not appear in this because there was no instances showing any of the lifts happening, causing accidents, but we want to see this, of course, as a positive situation. So again, we're looking at 13 incidents over a span of 9 months on a community of 1,700 units. So I think the numbers are very comforting if that's what we're looking for. Here we see more or less a third share of the proportion of enhanced vehicles. So we have different degrees based on the historical situation of the fleet, of what the customers have been ordering and so on. So basically we have a third of the fleet is more or less equipped with fully enhanced systems. Some are not totally, and some have warnings or alarms and so on. So of course, we want to have a look at what happened in all these instances. So what we did was try to understand what happened in the cases where, unfortunately, as the reporting showed, there had been some aircraft damage caused by enhanced GSE. And we realized from the information that we were reported that 2/3 of these cases, and again, we're looking at 13 events, so these numbers are very, very small. So we're looking at 4 or 5 different instances here. The main culprit was docking procedure not being applied or the anti-collision system being deactivated. So lack of respect of the procedure from what we've seen. Then there was one technical issue. One event was caused to severe weather, a storm, I understand, so the content was because of an outside factor. As Harvey also was mentioning, I mean, systems, different systems have different logging and memory data. So we did another exercise. We took a look at one of the loaders which we have in Brussels, operating in our headquarters in Brussels, out of our home base. It's a triple cargo loader. The triple system has a 3-day memory of recording instances. So what we did was we just looked at a week of operations. And in this one particular case, we did see that the data was showing that there had been 2 activations of the system and no aircraft damage. So the conclusions, of course, we were all saying, Stephen was saying before, these are early days. We are just starting to gather data. There's a huge amount of GSE out there, number of airports, different kind of operations. So the initial findings, if you like, or what we are drawing as a conclusion is that we believe as TCR that enhanced systems on the GSE are effective in preventing aircraft damage. We also believe that to have this happening, there has to be a high level of compliance on behalf of the operators. So engaging, disengaging the systems, being well maintained and looked after, and not allow any deviations from the process. And as TCR, we always recommend, we usually go for GSE at the highest level and standards because, of course, in our business, it's easier then to promote and to put into service GSE with higher standards. But anyway, we always advise our customers to choose the GSE, which also has an enhanced system, because from what we've been observing, it does prevent aircraft damage. Sorry, I skipped one there. Yep. So I'll leave the word to my colleague Bartu.
Thank you. I need to figure this out first. Hi, good afternoon, everyone. So I'll give a quick view of Donata perspective on this study. And after that, I'll talk about an industry survey that we performed. We wanted to pick a station with maximum number of turns and a good number of equipment that's already installed with enhanced GSE. That's also categorized as enhanced GSE. So we picked a station with 12,000, more than 12,000 turns per month, where we have 45 equipment that's already installed with this system and running for close to 3 years. And when we looked at the operating hours today, totaling around 100,000 operating hours. So these units have been actively used. So we were hoping to get good insight on as these were frequently operated. And we have 21 steps, 15 belts, 4 high loaders, and 5 medical lifts in this. And most importantly, we were looking for answering one question: does it deliver its promises? We are making all this investment in this kind of technological enhanced equipment. But is it actually working? Is it actually preventing damages? So we looked at our incident database to see whether we had any incidents that resulted with aircraft damage where this equipment was used. And we also checked if this system was active at that time or not. So you don't see this, I don't know why, but above that aircraft damage incident rate, you should see big 0%. So we had no aircraft damage, no incidents resulted with aircraft damage when these units were used and the system was active. So that's an important element to highlight here, because we actually, A, reduce the amount of incidents, B, also there's a cost element. That's one indication in this exercise. And it's important to highlight the cost element, because I see it as part of purpose. Our purpose is to reduce ground damage, reduce the cost of the industry. Therefore, we can invest in the right areas, we can invest in the technology, and then make this industry more attractive for younger talent. So in terms of how this cost avoidance model works for Donata in this specific station, so we looked at passenger steps example, where 21 steps have done more than 5,000 operating hours. We make some assumptions on aircraft connections. We said this makes more than 10,000 connections, which means 5,000 plus turns. And if we take the turn cost avoidance rate, as per IATA's future projections, we can avoid up to $165,000 since day one. It can be from $0 to $165,000, somewhere in between. But we wanted to understand the maximum. That's why when we were looking at our assumptions, we did not assume, let's say, non-utilized equipment. We did not assume non-engaged systems, etc. We say, let's say these equipment 100% engaged, this enhanced system, 100% is engaged, and equipment is used at its max utilization levels. So this would be the maximum cost avoidance for 21 steps. On the belt loader scenario, this cost avoidance can go up to $750,000 due to the number of hours that we've done and the number of turns we have performed with these units. So it's very significant. But one thing I want to highlight, this doesn't mean a cost reduction for ground handling. Right? It is a cost avoidance to the industry by not damaging the aircraft. And it includes all the direct and indirect costs that Steve mentioned earlier. We wanted to understand the industry application. So who has been using this system? What's their experience? We wanted to hear from people. This survey is currently having 21 respondents. When we prepared this presentation, it was 18. It will stay live until we end our study, so you're welcome to join and provide your feedback as well. But I want to give some initial insight information. So 72% of participants operate GSE with enhanced GSE today, enhanced systems today. We consider these are still early stages, but 72% already started using this equipment. So that's not a bad number. And when we asked about the distribution of these units in their fleet. We have cargo loaders, belt loaders, passenger steps, and medical lifts listed here. We see on passenger steps, 42% of participants said more than 70% of their fleet is already equipped with this. There's a big swing on passenger steps, though. 35% said less than 5% of their fleet is installed. So at least there are people who are ahead of the curve. Let's say there are some stations or handlers that do invest in this, and some of the others are starting to do that. Of course, it all depends on the equipment replacement plans or new introduction, or if anybody has any retrofitting programs, but it is happening. One thing we wanted to confirm for sure is that these equipment work. Again, we asked the participants, have they faced any incident with these units? And 80% confirmed no incidents at all. The remaining 20% said maybe, so they wanted to leave it maybe vague, or maybe they didn't have the inside information yet, but 80% confirmed straight no. And we were giving examples as well as we go through our study, and we had a number of calls sharing views. We've said we don't know the percentage of engagement. This system needs to be activated by operator, but we don't know whether these are engaged 100% of the time or not. So what we said, we asked the participants whether they included this engagement as a standard in their SOP, in their operating procedures, and 80% confirmed yes, they did. We have some learnings, and also we noted some improvement areas. By now, we have confidence that these systems do prevent aircraft damage when they are activated. But it takes me to the other question: how can we track the activation percentage? Today is unknown. Yes, the IATA requirement mentions that once the system is engaged, there shall be an indicator for the ground personnel to see. But is that enough? Should we make it a bit more strict and maybe make this as a standard rather than asking the operator to engage? I know it will bring some technological challenge, but technology advances faster than we think, so we can find a solution to that. So that's open for discussion. Once the system detects a compression, let's say, against an aircraft, it locks the machine, and then it needs to be overridden or resetted. So we again ask our participants whether they have assigned their breakdown teams or operators or someone in charge of turnaround to do that reset. So 80% confirmed they do. The resetting function sits with the breakdown teams, so the technical team reports to the scene and resets the unit. 20% mentioned that they leave that responsibility with the operations. Maybe we need to have a debate about which is the best party to give that responsibility to report to the scene, inspect the aircraft, reset the machine, and then carry on with the operation. And the element of data retrieval, so the machines store the data. Some of them you can download directly through a USB. Some of them you have to physically go to the unit and check the screen that's on the machine. We need to standardize that. Different manufacturers have different approach. And through the survey, we understood 40% of the participants don't even retrieve the data. But what can we do with that data that's already available in the machine? How can we collect that information easily, and how we can work on it to maybe support our exercise about cost avoidance and future projections? And the last element, there were some debates before as well about the retrofitting feasibility. When you order a machine today with this system installed, there is a cost, but if you want to retrofit an old unit, the cost goes, in some cases, 2-3 times higher than buying the new asset. So majority of the participants expressed that they are not having a retrofitting program. But how can we maybe address the concerns of retrofitting to make it easily or easier to retrofit those units is another discussion point. So these were our let's say, insights so far. The study is continuing. We will have the initial report in Q3. as Steve mentioned. And then probably we'll come up with some actions and further developments of the systems, working with the manufacturers and the colleagues in the industry. So thank you very much. I think we'll have the Q&A session. Right?
Yep.
Here you go.
Right. So we have some time left over for questions and answers. That can be done through the microphones in the auditorium itself, or you can do it through the app. And with luck, the question will pop up here on the screen, and I will read it out. So, do we have any questions from in the audience? Yes, please. If you wait a moment, Dominique, there will be a microphone shortly.
Simple, embarrassing question, as usual. The investment cost for this is on the ground handler. The cost avoidance is on the airline. In some day, if we want to influence the business and make less damage, we have to share the cake at the time, no? That's all. It was not really a question, so.
Yes. In actual fact, we have been very careful in the discussion for this session and with the players we have on the stage, that we're talking about this is an industry cost prevention. And we wanted to make that clear to everybody. And I think it was mentioned in the CEO session this morning that we're here to improve the industry. It's not about whether I can make this saving or you can make this saving. It's about making our industry as a whole more cost effective. So comment.
Steve, all the way back in the back over here. You can't see me because you've got...
No, I can't. I'm staring straight into the sun. Thank you.
So, Thomas from ACI. Question for Bartu, actually, and well, probably for the whole panel, but really for Bartu in terms of the presentation you just gave and the data you were giving in terms of feedback from the survey that you got or that you conducted. It seems to me that there's a bit of a contradiction. We have really good technology which is available for the equipment, yet it isn't automatically activated, for one, when it's put on the equipment, and it isn't by the GSE manufacturers standardized as a rollout for new equipment, at least from what I understand from what you were just saying. So, if you think about sort of basic systems that you have on vehicles, we all drive cars, well, a lot of us, I imagine, drive cars. We have reverse sensors, little things which beep when you're going, too close to something, either backwards or forwards. These have been rolled out on cars for years now and have driven the cost down for the deployment of these types of things. So would it not make some sense to be able to drive towards standardized implementation of these types of technologies and to avoid additional costs or avoid, let's say, overpriced or over additional payment which is needed because this type of technology is being implemented? So that's the first question. Don't know who wants to answer that. And the second one is, does it not just make more sense to activate it as soon as you turn the key on or push the start button on the GSE rather than having the operator to activate the equipment? So, please. And
Thank
otherwise,
you.
there's Steve in front of me who has questions.
I'll just say an answer for your first question, absolutely. For the second one, regarding automatic starting, I think with some of the equipment design, there was a concern about driving the equipment on the service roads, and that when the system is engaged and always detecting an obstacle, it had to frequently slow down. But I think this is why they asked the operator to switch on the system when they are closer to the aircraft and you're going to approach the aircraft. But we had some internal discussions. I think there are some ways to avoid that, and maybe use some other means to detect that this is closer to aircraft. Now the system can engage automatically rather than from the first key switch. But I agree that it has to be a standard, and it should not be left to an operator to engage manually.
I think if I can pick up, you made the point about rear parking sensors. So I'll give you the position that you may have 2 cars at home, one without parking sensors and one with. And if you drive predominantly the one with parking sensors and you get the one without parking sensors, at some point you're likely to reverse into something. And I think there's a concern, certainly in some of the organisations, that by having mixed fleets, because they don't all have enhanced, they have a mixture of standard equipment and enhanced equipment, that operators, there'll be some confusion with operators, and that has slowed the uptake in some stations. But we should get to a point, we need to drive it forward because it is benefit. Most of the systems are passive, so they're there and they do their job. They don't perform any differently to a normal asset. I mean, they control the speed, but that's all good for the operator as they approach the aircraft. But we need to get into people's heads that they should be using the systems, and there's no real difference whether they've got the systems or not.
Stephen, I would also like to add a bit of, even on a time frame perspective, the enhanced systems came out for July 18. And we all know what's happened in the last couple of years. So, what should have been the growing momentum of enhanced GSE coming out on all the new GSE came to a halt because of COVID. So, I mean, even the growing curve of seeing GSE being rolled out in bigger numbers. Let's not forget, this is not automotive. I mean, the numbers are relatively small compared. I think we lost a bit of momentum because of COVID, so we're probably going back into sync now with the manufacturers going back into the processes. And yes, I think also a bit of more standardization across the systems would help the operators to be more, to adhere more to procedures.
Thank you very much, everybody. I'm sorry, there's no time for any more questions, but please feel free to contact any of us during the course of the event. And I'd just like to thank you all for being on the stage, supporting us and supporting our projects. Thank you very much.
Thank you.